Anybody? I heard it. What is it? The growth factor. Actually, so now we're seeing that, okay, any particular exponential growth has more than one growth factor, okay? So we emphasize the one unit growth factor, but now we're seeing that within a given situation you have many, and that's what we'll keep talking about today. All right, what is a growth factor? In one word, what is it? What's a growth factor in one word? What's that? A multiplier. You got it. All right. And what is it a multiplier on? It's on output. A multiplier on output to get another output, okay? To get another output. And we've seen that there's this relationship between if you have exponential growth from the growth factor, there is consistent what? What do you have a consistent? What kind of change do you have that's consistent if you have a growth factor or exponential growth? What kind of change? Is it constant rate of change? No. So what kind of change is maintained when you have a growth factor, when you have exponential growth? What kind of change? Okay, we're multiplying with the growth factor. What kind of change do we get? Consistent. That's not consistent. Consistent. Percent change, right? Percent change. Remember that? And from the growth factor, we can get that percent change, and given a percent change, we can find the growth factor. Okay. All right, so let's just jump right in here. So here's, I hope you can read that. It's a little blurry. Okay, you good? All right. So here's a situation. So given a mass of bacteria, so this is from an older edition, and I like this problem, so we're going to do it. Given that the mass of bacteria in a petri dish doubles every 7 minutes, starting with 50, complete the following table. Okay, we're going to ignore the center column. We're just going to work on these two columns. So we got elapsed time and mass of bacteria. So these relationships are all about input and output, especially when we get to talking about the growth factors. You really got to have your input and output straight. So which is the input and what is the output? What's that? Yeah, so our input is going to be elapsed time. And then our output is going to be the mass. So we have some information here. It says that starting at 50 micrograms, so at time 0 we got 50, and if it doubles every 7 minutes, then what can you conclude right away if it doubles every 7 minutes? At 7 minutes it'll be how much? The mass will be 100. Okay? So can we kind of summarize this? If this mass is doubling every 7 minutes, what can we conclude? What do we got? It's doubling every 7 minutes. Can we represent that mathematically? Doubling every 7 minutes. What's that? I'm talking about the centerpiece of exponential growth. Growth factor. So if it doubles every 7 minutes, what's the growth factor? What is a growth factor? It's a multiplier. What is it? 2. Doubling is a growth factor of 2. Doubling is a growth factor of 2. Which growth? So now we're saying in a situation we have many growth factors, not just one anymore. Which growth factor is this? This is our 7-minute growth factor, and it equals to 2. So now we said growth factors are multipliers on output to give the next output. But now that we have many growth factors, input comes into it. Where do we? So in this right here, where do you see input? 7-minute growth factor. Where is there a reference to input? The 7 minutes, right? So the 7 minutes is saying that if we advance 7 minutes, this is saying that if we advance 7 minutes of input, our output is going to be doubled, or our output is going to be multiplied by 2 over those 7 minutes. Okay, so now with many growth factors, we have input involved, right? So we've got the 7-minute growth factor is 2. Okay, so, but what we'd really like is 1-minute growth factor, right? Because this is like the 1-unit growth factor. Okay, so remember that. What is our general form? We're gonna. What was our general form for exponential formula? So remember what the formula is generally for equals a
times
b to the x. Which of those is the growth factor? B. Okay, so we're going to call the 1-minute growth factor b because we don't know what it is. So how can I express the mass of the bacteria after 1 minute? How can we use what we've got so far and express what the mass of the bacteria after 1 minute would be? Yes, sir? He wants 50 times b. What do you think? Agree with that or something else? Yeah, Alex? I want to express this mass right here. I want to express this mass in what we have so far. So what do we think about 50 times b? Yeah, because what is the 1-minute growth factor? It's the multiplier on output to give. Now this is how much. So now your input is advancing 1 minute, and that multiplier is going to give you the new output if you advance 1 minute. All right, so this is how we get the next output for a 1-minute advance would be multiplying by b. Okay. So then from there, how could we get the output at 2 minutes? Which one? Multiply what by b?
1 by whatever's in 1, you multiply by b.
That's it. So whatever's here, we're going to multiply it by b. Okay, and so we just keep doing that. Every time you multiply by b, you're going to get the next output 1 minute later. Okay, don't tune out and wait for the punchline. This is the punchline. This kind of understanding of what's going on will allow you to do any kind of problem. So don't wait for the steps or the formula that's coming at the end, because what I'm showing you is something that's much more powerful than that you could just take any exponential problem, you could work it out. You could figure it out if you really understand what's going on here. And so when you're doing homework in this whole module, every problem that you do, you're looking for the growth factor. You're looking for repeated multiplication of the growth factor, even if they don't ask for it. Just take the initiative to kind of be creative and ask yourself, how does this fit into the big picture? Okay? Instead of, how do I get an answer to this problem so I can get the homework done? All right, so then what's true here? To get from 50 to 100 via the 1 minute growth factor, so how could I express 100 in terms of the 1 minute growth factor? So if I took 100, what does 100 equal? 50 times b. So 7th, right? So it'd be 50 times b to the 7th. Really important. You can see that you start with 50. If you multiply by the 1 minute unit growth factor 7 times, you'll get 200. All right, and so this allows us now to find what that 1 minute growth factor is. So let me rewrite that. So let's do it the other way. 50b to the 7th equals 100. And so what does b to the 7th equal? 100 over 50, right? Which is? Well, that makes sense because we already knew that. Because multiplying by b 7 times is equivalent to doubling 50, right? Multiplying by 2. So that should make perfect sense. And so now we can get b. How do we solve for b there? We're going to take the 7th root of each side. So to take both sides to the 1/7. And that is our 1 minute growth factor. Okay, so now I want to use the 1 minute growth factor to find the mass after 1 minute. Go. Use the 1 minute growth factor to actually do a calculation now. You're going to get a number. Find the mass after 1 minute. So this is going to be 50 times?
Oh, 50 times 2 to the 1/7.
2 to the 1/7. Anybody have that yet?
Yeah, it's 55.2.
55.2 is what I heard. 55.2. Which is 50 times b, or 50 times 2 to the 1/7. Okay, so now I want you to write the function g of t that gives the mass after any number of minutes. So if t is number of minutes, what would the function that gives the mass after t minutes, what would that be? So let's start getting you guys involved here. Zachary Roy, can you do it? You're up. Raised to the, I didn't hear you, what power? X? What's our input? Then I'm, yeah, t. You still see the t?
Yeah.
All right, so that's a t there, okay? So yeah, 50 times 2 to the 1/7 to the t. Okay, and that can be written as 50 times 2 to the t over 7. But I prefer this, okay? I prefer the 50 2 to the 1/7 to the t, and here's why. Because I don't remember quickly what growth factor is what. When I look at that, I don't see what growth factor is what. But if you just have the input variable by itself as the exponent, all right, if you just have the input variable by itself in the exponent, then this will be the growth factor for whatever that unit is. So I like this better because now I see that 2 to the 1/7 is the growth factor for whatever the unit my input is. And what's the input of my unit? What's the unit of my input? Yeah, but what's the unit?
Minutes.
It's 1 minute, right? Each t is 1 minute. Therefore, this is the 1 minute growth factor. Okay, so you can write it this way. That's fine, but I prefer this way because I can quickly see, oh, my 1 minute growth factor is 2 to the 1/7. Okay, so now I want you to find the 4 minute growth factor for this problem. Find the 4 minute growth factor. And explain what that is to the person next to you. So find the 4 minute growth factor and explain what that is. Okay, Stephen Wicker. Where's Stephen? Where's Stephen Wicker? Okay, Con. Where's Con? Did you get the four? So, did you get it? 1.2. And how did you get that? Can you represent it exactly? So what exact value is that? Like for instance, 2 to the 1/7. That's an exact way of representing it. What about the 4 minute? And then if we want what we would get if the input advanced 4 minutes, what would we do? I think you had it. Raised to the, yeah. So every minute you're going to multiply by 2 to the 1/7, so that by when 4 minutes have gone by, you will have multiplied by 2 to the 1/7 4 times. Okay, so now I want you to use the 4-minute growth factor to find the mass after 5 minutes. How could you use the 4-minute growth factor to find the mass after 5 minutes? So we're asking about this one right here. And use the 4-minute growth factor to do that. Can you do it? If not, get help. How can you use the 4-minute growth factor to find that mass right there? Matthew, you're up. Did you get that? How could you use this 4-minute growth factor to find the mass at Armas, right? Matthew Armas, right? Yeah.
You would multiply 2 to the 1/7.
Okay.
To the 4th.
To the 4th.
You would multiply it by 2 to the 1/7 by again.
So you're gonna
That's what I was thinking about.
that you're gonna multiply this times 2 to the 1/7, and that will give you the mass after 5.
Yes.
Okay, so where is Kyle Roach? Where's Kyle? He's usually back there somewhere. Not here today. Okay. Where's Yusuf? Did you hear what he said? He said to get this mass at 5 minutes, take 2 to the 4-minute growth factor times 2 to the 1/7. Do you agree with that? You said when you said the first one, do you mean this value? This one. You want to take this value and multiply by 4-minute growth factor. All right, so he wants to take this value of mass and multiply by the 4-minute growth factor. Do you want to change your mind, or do you still want your original?
Aren't they both the same?
Both the same. Okay, what I heard you say was just take the 2 to the 1/7 times this. He's saying take this mass times this.
Oh.
You agree with that?
Yeah.
Is that? Yeah. So you're going to take this mass. If you multiply it by the 4-minute growth factor, it's going to advance you. It's going to get you the output for 4 minutes later. So if you start at 1 minute and you multiply by that output by the 4-minute growth factor to the 4th, it's going to give you that mass. Anybody get it? So if you take 50 times 2 to the 7th, and then times 2 to the 7 to the 1/4. Tell me what you get. Just shout it out. What is it? 82.03. Someone else get that? I hope you're bored on the test too. That means it's easy, right? Okay. All right, so questions on that. So see, we got all these growth factors now. We got the 7-minute growth factor is doubling. We got the 1-minute growth factor is 2 to the 1/7. We've got the 4-minute growth factor, which is 4 of those multiplied together, which advances us 4. So what about, I want you to write a function for called f of h, which gives the mass of the bacteria h hours after the initial time. So again, f of h gives the mass of the bacteria h hours after, I'll just say later, I'm running out of room. So h hours later, okay? So can you write a function for f of h, where h is in hours now? See if you can do it. Okay, let's see how it went. So Rachel, so in order to do that, there's really kind of just one thing that you need. What's the one thing that you need to do that?
60 minutes times h.
Okay. So, and what do you tell? What just in general? What is that? What are you telling me? Like, what do we need to do this? Okay, exponent would be 60. That would give us an hour. So, what is our general form for the exponential function in general?
So the initial amount of
Right.
bacteria, so
50.
times your growth factor.
Growth factor. That's what we right. The growth factor for how long?
60 to the h.
So, we want which growth factor is going to go in here? Nice and loud. Sorry. 2 to the power of 1/7. Is that it? And then, if I do it out here, is okay? Is this what you're saying? So we need to do the mass h hours later. We need the 1 hour growth factor, and 1 hour is the same as 60 minutes. So to get the 1 hour growth factor, you take the 1 minute growth factor and raise it to the 60. So if you took the 1 minute growth factor and raised it to the 60, you got the main point. You got that. Okay, so again, we could write this, we could rewrite this as 50 times 2, and we could combine all that stuff, 60h/7. But I like this better. Why? Because you can see every growth factor. What's the 2? Which growth factor is that? 7 minute. What's 2 to the 1/7? 1 minute. What's everything in the parentheses? The 1 hour growth factor. So you can, so this way you can see all the growth factors. Everything in the parentheses has to match that unit right there. If that's in hours, then that has to be the 1 hour growth factor. And it is. So you can rewrite it this way, but then it's hard to kind of pick apart what's going on. Here, I like this form much better. So 2 to the 1/7 is the 1 minute. So raise that to the 60th. That's your 1 hour growth factor. So that's what your growth factor for this function is, raised to the h. Any questions on this example? Okay, so you're going to work on number 6 on page 140. And I'm going to give you some additional questions. Anybody have a question about this one? Lots of good stuff. I mean, this is lots of good stuff here. It's using everything we've learned. Okay, so the gist of this is that you take some ibuprofen, and then every 5 hours, your body removes 85%. So your body disseminates 85% of what you took 5 hours ago. Okay, so we'll let T be the number of hours after the dose, and B will be the amount of the dose remaining in your body. Okay, so it's the amount of the initial dose that still remains, that you still have in your system. Okay, so in addition to problems, so the problems I have include A and B. So this is what I want you to do. I want you to let N, so T is the number of hours. I want you to let N be the number of 5 hour periods. And I want you to write the function for N. And then I've got some others here. So T is the number of hours, like we said. So write that function and find the 1 hour percent change. M is the number of minutes. Find the 1 minute percent change. And then D is the number of half days. Find the half day percent change. Okay, so remember that this is decay, and decay is a little trickier. Decay, you always have 2%, right? What are the 2% that you have with decay? The change or the decrease, and remaining, or what you keep. Which one gives you the growth factor? The percent decrease, or the part that you keep? The part you keep is the multiplier, right? So to keep that in mind, go slow. So that's a little trickier with those growth factors with decay. Okay, so I'm going to take roll, and here's your task, right? Here's your task to work through these questions on the right. Is the 5 hour, the first thing we need is the 5 hour growth factor. Is it 0.85 or 0.15? It's going to be one of those two. What you keep, 0.15. So every 5 hours, to get the next output 5 hours later, you multiply by 0.15. 0.15. Okay, therefore the function is initial amount times 0.15 to the
N.
Notice, what's the unit on N? What's the unit on N? 5 hours. Therefore, what's in the parentheses is the 5 hour growth factor. Okay? Number of hours. Okay, so we're going to do this one more time because it's really important. So now we're asking for some value B. That if you multiplied by B, you'd get the amount remaining 1 hour later. Okay, so how can we relate our B to the 0.15? How does B relate to 0.15? B multiplying by 0.15 is the same as doing what?
Multiply by B 5 times?
Multiplying by B 5 times. What do you think? That's it. So 0.15 is equivalent to multiplying by our 1 hour growth factor 5 times. Therefore, B equals?
Equals 0.15 to the power of 105.
Very good. That's it. Okay, so just want to be able to see. Multiplying by 0.15 means multiplying by B 5 times. That's exactly what that math statement says. Multiplying by 0.15 is it's the same as multiplying by b 5 successive times. So therefore b is 0.15 to the 1/5. Therefore our g function is 500 times 0.15 to the 1/5 to the, how's it going so far? All right, now the percent change. How do I find the 1 hour percent change? So you found 0.15 to the 1/5 first? What is that value? So the 0.15 to the 1/5 is 0.684. So that represents 68.4%. Is that the percent change?
No.
That's how much you keep. Therefore, how much you lose every hour is, what did you get? 32.6. So the 1 hour percent change is 32.6. Sorry, 1. Always with decay, just always get the two percentages, and then the one that you're keeping every unit corresponds to your decay factor. And then the other one is the percent change, or the decrease. Okay? All right, minutes. How am I going to get, if I want the function for minutes, then what do I need? So this black, 500. What's going to go in the parentheses? What does it mean, though? What is the meaning of what goes in the parentheses? Taz? I think you skipped ahead. Try again. The one. But in totality, in the parentheses, what is that? What is that thing? Taz. The 1 minute decay factor. And how did you get it? So you're going to take the 1 hour growth factor to the 1/60th. Agree? 0.15 to the 1/5. And take that whole thing to the 1/60th. And then that to the m. So everything in the parentheses that you're raising to the m is the 1 minute decay factor. Okay, so when you multiply all that, get all that stuff, what do you get in the parentheses? 0. Point what? Did anyone do that? 9985? 35? All right, 99.35%. Is it the amount we keep or the amount of decrease?
The amount we keep.
Yeah, which makes sense because in a minute, only a minute, you're going to have most of it, right? You're still going to retain most of it in your system. So think about it. Should make sense. Therefore, the percent change is 0.65%, less than 1% that you lose every minute. Questions so far? Okay, finally, half day. Who wants to do this one? Volunteer. Somebody new. How about Byron behind him? Or, go ahead. Jacob. Is it Jacob? No, Joseph. Go ahead, Joseph. 500. So we took the 1 hour growth factor, and to get the 12-hour growth factor, raised it to the 12th. It's in 12 hours, you will have multiplied by the 1 hour growth factor 12 times. So you're going to take the 1 hour growth factor, multiply it together 12 times to get the half day. That should be a D, sorry. The half day growth factor. And what'd you get for the number inside the parentheses? So, did you get the number before it? Do you have the number before? So what's this number right here? 5? So that's our 1 day, or half day. That's our half day decay factor. So that corresponds to 1.05%. So Joseph, is that amount we keep or lose? What we keep. in a half a day. So therefore,
You take one off that.
does it make sense that in 12 hours you've lost the percent change is 98% of the dose that you took 12 hours ago? Does that make sense? Yeah, because this stuff only kind of, ibuprofen works for like 3 or 4 hours, right? But there may be a little bit left after 12 hours. Okay. Any questions on all those? Okay, so, yeah, sure.
So for mine, I did the half-life for the half-life problem. I just took your F of n value or whatever, and then I just raised that to the 7, and I didn't get the correct answer.
You raised something to the 7th?
Yeah, when you have your initial 5-hour period,
Okay.
I just raised that to the 7th. I thought that would work. I was just wondering why it doesn't.
But so where's the 7 coming from? Why 7?
Because, so that's your 5-hour period, so I figured 7 multiplied by 7.
Yeah, so that raising to the 7th would give you like a 35-hour, that'd be like a 35-hour growth factor, or decay factor. Okay, anybody have a question on this one? Okay. All right, so do you want to see walking or acting? Oh, I heard acting. Okay. All right, so my daughter Emma is a budding actress. She had her first. Let's see here. There we go. There's my beautiful wife. She had her first role here. Where is it? Oh, we need sound. Darn it. Okay, so her first role was as a minion from Despicable Me, and she played the part perfectly. Here we go.